So let's start. Uh-huh. Okay, so my name is Bartosz Sypytkowski. Here are handles on how to reach me out. There is also a blog post that I'm having for something like 14 years right now. And yeah, for the context of this talk, I'm working with CRDTs as a passionate programmer and for recent years also professionally for almost 10 years right now. And I was working as part of Akka.NET project in F# projects as well. Back then I was also pre-COVID, I was working with Ditto, which you already might have heard about today from Annette. And for last 4 years almost, I'm working together with Kevin on Wires project, which is basically a Rust port of YJS that is basically a foundation for building conflict-free replicated data types in Rust, but also as a foundational model for other languages like .NET virtual machine, like Python, Ruby, Elixir. Also, from what I know, there are ports in Go, Dart, and so on. And our talk will be also oriented around local first software, but in this context, it will be on the software side in terms of how topic heavy we are. There will be a little bit more meat, let's say, on the second half of the talk, but first we need to cover how the world of programming, how the world of software looks right now, how it differs from 20 years ago, for example. And is it good, is it bad, and what can we do about it, right? So let's start with services. Why are we using services at all? Because it is not ever-present concept, right? Let's say 20 years ago, when you were talking about services among non-developers, right? People will mostly probably recognize this word around somewhere in the Windows system where something got crashed and you need to scroll down over 20 pages of forum sites to discover that you need to turn off some service. And it was usually not very nicely correlated word in the sense, but nowadays everything is a service. Like we are building web services. Who is building web services right now? Okay, still. And maybe one more question. Who is or has experience in venture-founded capital startups? Yeah. So we will also be talking a lot about those. So yeah, but why do we need them, right? Why, let's say, Winamp is not enough anymore? Why VLC is not enough anymore? Why, how to say it? How, let's say, why we are using games as a services, and so on and so on. So changes have happened during the last 20, 30 years. And in the past, in the 90s, for example, I was one of the first computer owners in my block. Well, my dad was, because we have one computer over the entire family, and we were one of the few computer owners in the entire district in the 90s. Nowadays, things have changed, and most of us have several different computers with us all of the time. I have laptop, I have smartwatch, I have smartphone, I have also PC, I have tablets, I have several gaming consoles and stuff like that. And with those, expectations have changed, not only mine personal, but also many people who share the same problem, right? So if we want to, for example, listen to music, we don't want to compose some playlist on our PC, right, back at home, and not be able to reach it throughout our travel or something like that. We want to be able to reach anyway, anytime, and we want to be able to edit it anywhere, anytime. And this is why services also, one of the reasons why services are so popular, because nowadays you have Spotify, and as long as you have internet connection, or if you are paying for premium, of course, you can also have an offline support to some extent, and you can use those things that you have built, those things that your playlist, your music, and stuff like that, you can share it among all of the devices that you have. Other thing that has changed is also how internet changed the way how we function as a society in the terms of some time ago, when you wanted to find your like-minded people having the same kind of problems like you need to find out some ERC channels, maybe forums oriented towards specific domain of problems, right? And nowadays, everyone are using social networks. Everything that we are creating, basically, we want to share it with others. And this also changed the expectations about what our programs, what our software should provide, right? We want to be able to share our data with basically anyone. And this is also where services are so useful and so common. So what if we would like to, for example, build a service for our own, right? So we basically need to have some wallet that we are able to pay our salaries to be 24/7 available for usually some kind of cloud provider or something. And let's start and build something, right? And then there is a first issue. Those things can get pricey, especially if we are talking about popularity. For example, we created something that is useful. Somebody, some tech influencer, I don't know, Marcus Brownie, Linux Tech Tips, discovered it and featured it on YouTube or anywhere, right? Now our popularity has skyrocketed. And what happened? The AWS bill comes in, right? Here are examples when people get overnight, something like $60,000 overnight, right, in bill pricing. Now, who is able to basically pay this price from their own pockets? We cannot, right? So what do? Well, we go to venture capital and, well, let's maybe go back a little bit. Why is this so pricey? Because, well, AWS puts a markup on top of everything, starting from disk storage through virtual machine uptime to egress and egress network and stuff like that. And it all seems pretty cheap as far as we are not successful. Once we are, or once we are not very good at optimizing stuff, then cost starts to spike, basically. So back again, what can we do? Of course, we can go to the venture capital and start some kind of seed round, maybe get 2, maybe 10 millions, depending on our idea and selling points. But it turns out that this is also my experience, that most of the venture capital funded startups die, and they die early. And one of the reasons is that even if you are successful as a company, it doesn't mean that you are successful in a return of investment for those startups, because our investors are not interested in giving you $2 million so they can get $2 million in 10 years, right? They want this project to be widely successful, because you need to return the risks, and you need to also return the risk on all of the 9 other projects out of 10 that have failed already, right? And on top of that, you need to earn the money. So what are we doing, right? Well, we usually, most of those companies are starting to develop some features that quite often nobody uses or nobody needs. Well, some build some hype maybe around AI, add some price hikes around subscription model and stuff like that. And eventually, we often become an epitome of what we tried to kill, because usually we are already providing something that already existed on this ecosystem, but let's say that we find out ways to make it better. But eventually, because of return of investment expectations that we have on us, we need to go back to the monsters that we tried to fight with, right? So this is a link from talk of Martin Klepman about local first software. And our incredible journey was basically a blog post about people who were part of venture capital funded startup, right? Where they were telling how much the fun they have building their software, how many new things they learned, and how incredible of incredible kind of work it was, right? And eventually, the startup failed. They bankrupt. But they have a lot of fun, and users are now, basically screwed over because their data is no longer there, right? So we would like to have software not only that brings fun, not only that allows us to basically earn money, but also build something useful, something that lasts, maybe even lasts longer than our own company, right? Leave some legacy to others. So, of course, it all comes down to money, and the question would be, how much money can we save and where can we save it? And most of the rest of the talk will be about different ways of doing that. Because if we save enough money to survive while popularity spikes, we can basically found our startup ourselves. And if we are able to eventually move all of the centers of the costs from ourselves, it means that this software will last even if our company doesn't, right? So, sources of cost. One is the cost of network, and of course this means hosting web services that I already mentioned about, hosting virtual machines, usually in some kind of cloud provider, but also if we have a computer in our basement, if somebody has enough money to have a house with the basement inside, then you can also host it from your local machine, but you still need to pay your ISP providers and stuff like that. Distribution, so how our application can be provided to others, and in web services, this is usually via browser. Even if there is some kind of App Store app or something, you still, quite usually, eventually, we still want to have some kind of a browser that will provide a rich internet application for our users without having to install it locally. Then we have data storage. So we need to be able to store the data somewhere, right? And cloud storage can be actually pretty expensive, even if it looks cheap in small scale. Once you reach certain scale, it might be much more expensive. Data management, so databases and many database providers provide their own managed services, and this is, of course, also part of the fact that those companies are also VC founded, and they also need to bring those money in one way or another. Usually, we are not buying databases nowadays, unless we are Oracle. We usually provide services of managed database providers. And of course, there is discoverability, so buying domains, DNS, stuff like that, which is, honestly, it's a very interesting topic because, in my opinion, the current capital model of domain trading is basically a kind of corporate blackmail. If you will see how many domains you need to buy to have worldwide experience for your brand, and usually if you buy one, soon after somebody else will scalp it under some other suffix domain, right? And then if you want to buy it back from them, well, I hope that you have several $1,000s in your pocket ready to pay for something like, name with different ending, right? And starting from scratch. So basically, we mentioned about costs of hosting, right? So this, of course, will be talk about local first. And this is the main reason why, because when we are talking about local first, we talk about peer-to-peer services. So services that are installed on user devices. Those devices communicate with each other in one way or another. Versus client server, so what we nowadays know as popular web services, right? So the issue here is that in web service model, usage, well, you cannot see it, right? Usage scales with the numbers of connecting clients. In peer-to-peer model, usage scales with the number of devices that start to cooperate with each other. Problem is that the costs don't scale with number of users in the client-server model, because we are the ones who are maintaining servers and we are paying for them. On the other side, in peer-to-peer model, well, peers are communicating with each other, peers are having those devices, and our cost is basically known because those are client costs. We are offsetting costs to our clients. Is it bad? Honestly, not. I was in several projects when we have like 2 teams of developers building an application that basically was consuming as much power as 1/4 of the smartphone, basically. And it was supporting hundreds of clients nowadays. And I see that this is like a quite common theme among the web services that, well, are not yet popular, let's say. Even once they are popular, for example, Stack Overflow uses something like 11 servers in total, which for the side of this cost, this scale is really, really cheap, I would say. And I guess that nowadays, if we want, we can offset those costs to client devices, because quite possibly having a virtual machine that is as powerful as the actual machine when the desktop client can work, it is magnitudes of orders of more expensive. Having user devices, and well, nowadays user devices are much more powerful than they were in the past, and we can use this to our advantage as software developers. Another part is distribution model, which in past was, well, it has various degrees, but nowadays it's much simpler, because pretty much every mobile provider has their own store, when we, of course, need to share part of our revenue with them. But in turn, they are hosting this for us. And there is always BitTorrent for those who want to just be able to distribute things in old style, just like, let's say, Linux distros, right? So we can also put those costs onto people that are already using this application. Regarding data sharing and backups, one thing that we should mention about is that it is not possible to have an application that is available to connect to anyone, anywhere, anytime without having some services. And the thing is that the best we can do is offset those to use services that users already are using. And part of that could be, for example, disk drives, because if you have Gmail or in general Google account, you have probably some sort of Google Drive. If you are having an Apple account, you have iCloud disk space that you get for free, you want it or not. And as far as you don't try to build, let's say, a second Spotify or second Netflix, those costs are bearable most of the time, because you can have your entire Notion workspace into some small, package, something like for sure less than 1 GB of data, right? And if you need something bigger, well, disk prices are very cheap nowadays. Like, if you really need to share multimedia of any kind, right now 1 TB of HDD costs less than $10. And if you need to share this data outside of your local PC, for example, you can do it over IPFS or torrent or SSH. N0 is logo of iRoh, which I will refer to several times during this talk. But the general idea is that you can have a machine that is like primary storage that works as a backup for other devices which can load your data partially. You don't have to load it all, for example, for your smartphone or something like that. But is it permissible, let's say, to have all of the data on your client devices? Well, arguably yes, because it turns out that, for example, Wikipedia, entire Wikipedia without multimedia that it has around 24 GB of data zipped, which is basically, using the previous example, around $0.25 in the user's cost. And I think that if you say for a given user that he can have like the biggest encyclopedia in the world for fractal of the price of regular paper book encyclopedia, they would agree on having something like that, right? Even if you need to add indexing and stuff like that, you still will be probably using less of it than it takes to install any modern game on your computer. And for sharing those files, I've already mentioned iRoh. iRoh is basically a networking framework that I was playing with recently, they are offering something that allows you to basically connect several cluster of devices through QUIC protocol, the same protocol that HTTP 3.0 is using. And it supports, well, a changed version of IPFS. So it, just like BitTorrent allows you to suspend and resume, for example, file upload, it can do the same with some checking along the way. So you don't need to download the entire package to verify that it has no bad bits, for example, inside. It can do it incrementally as you are downloading it. And they are providing several different libraries on top of that. One is dump pipe that allows you to basically use your devices as a relay to other devices. So when I was working in Ditto, one of our use cases was that, just like Annette mentioned, one of the primary providers was airlines, where you have, you are in closed space and you cannot connect to outside network, but you can connect to other people's within the same local network, right? And other use case was that, what if we have devices and applications that need to work in the mine shafts? You don't have access to the outer network, but you have a connection to your next peer. This next peer has connection to the next peer. There is maybe some relay router somewhere along the way. And eventually, you can reach the outer internet, like the wide area network, through this pipe of relays, basically, by basically proxying requests between different clients. And this is what the dump pipe also is able to do. And send me is basically an, I would say, simplified and also upgraded version of BitTorrent. It's very simple. It's like a single file over IROC framework, which allows you to basically send a file to another person by creating something that looks like a magnet link. And it doesn't require tracker servers. However, IROC people are hosting some network discovery, and we will talk about it a little bit later on. So for collaboration, and since I'm Wires developer, I need to mention Wires, also YJS. And to be fair, I also want to shout out to Automerge, which is our competitor, and Loro. And Electric is a little bit different, I would say, because all of those are frameworks that are using CRDTs. And Electric is a little bit different because it still works on the central idea of central server that is, well, maybe not primary source of information, but there's like a concept of an existing server and your local devices that have your data cached but available for modification locally. So it's great. I mentioned I worked with Ditto, but Ditto is closed source, so I didn't mention them here. But if you want, you also can use Ditto. For non-conflict free options, there are still good old known stories like, standard version control systems still have their uses, even if you want to integrate them with our own systems. For example, I would prefer probably to have Wikipedia editing not being automatic, because in general, I want to be able to control what I'm merging, what I'm not merging, right? So it would be great. And who of you heard about Fossil? Anyone? So for those who didn't, Fossil is a version control system which is used by people developing SQLite. And Fossil is built on SQLite. And so basically, it's SQLite as VCS, and as such, it has great querying support because you can use SQL queries to actually introspect metadata of your repositories. It has support for web UI out of the box, because most of us forgot that, well, there are quite a lot of you who didn't forget probably, but for younger audience, Git is not GitHub. Git itself has a lot of missing features, like issue trackers, like code reviews, like permission control to some extent, and first of all, hosting, because you still need to have a server that hosts, well, at least SSH server, where you can push your GitHub data. And those are not granted to you, right? There is like a company that makes a living for providing those missing features to you. And Fossil has a lot of these stored out of the box in the single executable, basically. So now let's come into the most problematic issue, because when we are building web services, the story is easy because HTTP have won. Everything works over HTTP, even if it's WebSocket, even if it's gRPC, it's still an HTTP communication, right? So we basically need to host HTTP service in our cloud provider, pay some ransom fee for having our domain registered, and then we are ready. And for serviceless communication, for peer-to-peer communication, it's not the same exactly, because now we have two sources of issues. One is, like I mentioned, wide area network, so how to these devices that have like no common point of contact can discover each other. And there is other, which is local area network. So even if we are in the same room, how our devices, how our applications on our devices can securely talk with each other, right? So let's start with local arena. And of course, first would be a Bluetooth, because it was hyped as solution for these problems, except it's not really a good solution, especially nowadays. One issue is about pairing, because it is, I would say, a user experience issue mostly, because we need to pair our devices over Bluetooth in order to communicate with them, and you don't maybe want always to communicate with pair with devices of people that you don't know, but you still want to share some data with them, right? There is also a problem at the architectural or conceptual level, because Bluetooth was originally built for signaling devices and some central devices. This is called central peripheral. So basically, for example, I have a heart rate tracker on my smartwatch, which is working as a peripheral. And there is the same application installed on my smartphone, which is in this setup a central device, right? So if we want to, well, one of them is producing signals, other is receiving them, right? So what if we want to build a chat application over Bluetooth? The response is on the image. Basically, both devices communicating with each other over Bluetooth need to work as central and peripheral. And another issue is about GATT. And GATT is like a core principle by which Bluetooth works. And GATT is basically a dictionary of key value pairs. And when you are getting information from Bluetooth, you are basically getting information that this attribute with this key has changed, right? Which is good if we are talking about signals, but if you want to stream some data, it is like very inconvenient way of doing things. And it turns out that under the hood, GATT is using something that is called L2CAP, which is like a streaming protocol over Bluetooth, except that many of the Bluetooth networks, many of the Bluetooth providers and libraries that we are using are not exposing those to programmer API, basically. Another issue is that Bluetooth is OS specific. It means that it has to be supported by your operating system. And those operating systems has varying level of support. By the way, older versions of Bluetooth were built on top of concepts of known as profiles, and this is nice trivia. There are 13 different profiles in old Bluetooth network stack. Can you guess why? Well, basically, when Ericsson was developing the Bluetooth as a standard, they've created 13 different committees. And decided that, of course, if we share the work between them, they will communicate with each other and figure out something, right? So now we have 13 different profilers, and those profiles are not compatible with each other. So sometimes, let's say that history of developing something leaves a mark on how things work up to this day. There is also, this is like a biggest issue of Bluetooth in this setup that we have here. Let's say we have a chat room when we are all connected, except the problem with Bluetooth is that it has max concurrent connection limit. I think it's about 7 devices. So you can connect to 7 other clients. So now we need to build basically a cluster of partially connected devices, right? And of course, there is a transfer limit because Bluetooth honestly is not very fast. And if you want to stream music, recent versions are okay-ish, but still, for example, almost all of the Apple devices like AirPods, AirDrop don't work over Bluetooth. They work over Wi-Fi Direct, which is basically a point-to-point Wi-Fi communication. So it is great. It works much faster than Bluetooth, and it's much easier to actually work with. But there is a problem. There was a problem about safe network discovery, safe peer discovery, to say. So we want to discover other peers in our local area network, but we don't want to hijack somebody because he just has his smartphone open, right? So how to do it securely? And Apple had their own internal protocol called Bonjour, which later on was standardized into something that is called MDNS. And MDNS is also something that needs to be supported on the operating system level. And I don't know how about recent Windows, but old Windowses allowed MDNS discovery only for printers for some reason. I don't know how it looks nowadays, honestly. But the general idea behind it is that we are creating a temporary DNS addresses similar to how regular DNS works. The thing is that usually those have the shape of some kind of UUID .local, and local is just a domain suffix by convention, really. So each of our devices connected to the same local area network has their own local URL. And basically, when we need to discover what is the DNS, we cannot ask central DNS servers because there is no such thing. So we are using a well, we are producing a UDP packet and sending it over multicast UDP. So we are basically sending it to everyone. This is why this needs to be supported on the OS level, because from what I know, you can correct me if I'm wrong, but from what I know, our OS network stack doesn't allow us to basically broadcast, do a multicast over over UDP addresses, IP addresses. So basically what we are doing here is we are sending a question if anyone knows what is the actual IP address of this service. In our case, one of those services knows because they are the owner of this address, and they are sending a multicast back, and then all of the other devices can update basically something that is equivalent of routing table to this new value. So now everyone are updated about how to reach us by those DNS addresses, MDNS addresses, and those are changing periodically. So they are not kept forever. And you can do it over JavaScript, for example, and this is a simple example. Like the API is very simple. We can create a service that can call advertisement about who we are, and we can create browser to discover other devices and just have a stream of data that allows us to connect to some specific hosts, let's say, with their own IP addresses, what kind of communication they support, what port they are listening on, and stuff like that. And then there is also wide area networks, so something much more complicated, honestly. And complication comes from one of the points, and that is whenever we are using something like ifconfig, ipconfig, we are not getting IP address that we are visible to publicly, right? Because between us and other devices, there is a set of routers and networks of different kinds. And this means that when we are reaching the outer internet, whenever we pass through a router of some kind, our IP address is being changed, basically. It is rewritten, stored in the router routing table, and sent forward, right? So now, how do we know how to connect with to another person, right? And originally, there was a protocol called STAN created for this specific reason. And STAN is basically the most simplistic way. Basically, there are big cloud providers that allows us to ask them about what is our IP addresses visible from their point of view. And since those are free, publicly available domain names, like stan.1 or L1, google.com, we can always ask them, and they will basically send our public IP address back, and that's all basically, except that routers don't store our address mappings for eternity, right? They have like refresh period when those entries are pruned, and this is usually around 5 minutes. So from time to time, we need to send ping backs to refresh those routing mappings inside of our router. So we're going close to the summary. So if you want to make our service discoverable, first let's make it configurable. Because if we are offsetting some of our application capabilities to other services, like network disk drives and stuff like that, sometimes people don't have access to iCloud or Google Drive. Maybe, who knows, maybe Google Drive won't be here forever, right? Google is also just a company. What will happen if Google will basically break and we won't be able to use it anymore? So it's good to use some open protocols that anyone can develop, like SSH, for example, if it's possible, as an option at least, because it's better to provide a little bit worse experience than no experience at all. What is important, make it efficient, because why Netflix infrastructure costs so much while the Pirate Bay can be hosted on a shoestring budget, right? One of the main reasons, is that Pirate Bay doesn't participate in this whole network traffic required by multimedia spreading, let's say, right? They are just a tracker server. Tracker server means they allows us to discover peers with each other, right? So this thing that we were mentioning earlier, we have publicly available domain of Pirate Bay, and they are participating in exchange information where to find other peers. Bootstrap server, it was put as an alternative to tracker server for WebTorrent. WebTorrent is basically a torrent protocol over WebRTC. And Bootstrap server is an idea that all we really need is to have access to at least one another peer connected to the network. And once we have it, we can reach other peers that this peer know about without asking a tracker server. And that's basically it. So it's even more efficient. And of course, if we can share some things, it's good to make them easy to publish in one way or another, because we are not having web services, we don't use URLs. We can use things like magnet links. SendMe, the application I was mentioning before, has basically something like hashed information within the message itself that can be published over Slack or anything really. And then you can use this information to access those services that you want to get some files from, for example. QR codes, because why are we constrained to use electrical devices all the time? Why cannot we use something that exists beyond the network? We as, applications don't work without people and without real world, so why not to use things that are not constrained to ones and zeros? We can use QR codes, you can use scan codes, barcodes, whatever we really want to. I've seen, okay, we are getting close to the end. So I've seen also some ideas about, for example, sharing network transfer through microphone and speaker, right? So basically one device is sending literal noise and other is hearing it and converting it into standard digital signal and digital payload. So there are more ways to think about solving problems than just TCP/IP stack. And that was basically a summary. So we were talking about things, how to build and offset cost of the services into peer-to-peer networks. And I think that local first software is really great in this regard, because it allows us to really move those things forward, and it allows us to build this was called commodity software. So basically a software that doesn't require massive foundings, massive groups of people, that we can go back to those days where we were building things for ourselves, but this time we can also meet the expectations that have changed over the years, so we can reach the people who think alike and also have their own needs and address those needs as well. So thanks. Those are also some links. I will post those slides later on. So this is talk from Martin Klepman. This is main site of iRoh. I recommend it. Lib peer-to-peer is basically a multi-language framework for building network protocols. And SQLite, what I didn't mention, SQLite also has CRDT extension that is separate from Electric, but I don't know if it's still being actively developed. So you can also have CRDT over SQL without all of the craft around it. So thanks.
We have a little bit time left for questions. You can take them.
Isn't WebRTC solving those WAN discoverability problems?
Can you repeat?
The WebRTC protocol.
WebRTC?
Yes. Isn't it solving WAN problems?
Sort of, because WebRTC also uses STAN servers under the hood. Because WebRTC is not like a single technology, it's basically a network stack. I don't recommend using WebRTC because the API of WebRTC is one of the most inconvenient to work with that I've ever found in any kind of APIs. So this is why I don't mention WebRTC.
Thank you.
Yeah.
Sorry if I missed something. So we talk about this, how to discover where the other IP is by checking out what the IP is.
Yeah.
But even if you have the IP of my home, it doesn't matter. There's a firewall outside of my home because my IP is shared by hundreds of people, right?
Yeah.
So how do you solve that bit?
So one thing I was working on recently, for example, is let's say that you have several devices and you want to have those devices connected to each other, right? So the idea here would be that, well, one way is to provide a third-party service, like for example, you have iCloud, and each of those devices leaves a little node file in the iCloud where can it be found, basically, right? And other devices who also have connection to iCloud reach for nodes from the other devices, so they know how to connect to them. And in this case, iCloud is our peer discover, let's say, right? Other thing is that what iRoh proposed is basically producing this is like a string of hexadecimal values that are later on encoded or decoded that you can share with other people via other communication devices like Slack or something like that, all right? And they can copy them to their own site and use it to basically connect to somebody else. Because this is not a simple problem. If your network is severed, for example, right, and or you are maybe traveling in a train and switching between different, your network address is constantly changing, there is no easy way to really solve it without having like third-party service. And this is why I also mentioned iCloud or Google Doc as a way of communication piece, right? That you can pick. So,
one of the things that you didn't go into, which I think are really important for these services, is like some form of identity. Do you have any thoughts on how you can establish identities in like service-less communication?
I would say that there are like two different bases to that. Well, several different aspects that we can look at it from different perspectives. One is for sure about end-to-end encryption, how to secure that. Other is about, because there is technically no this difference between multi-device and multi-user, right? So these are like multiple peers and this is multiple peers, except that in multi-device setting, you can have something like, for example, shared key, because you are the owner of those devices. You can manage this data, so it's easier to establish like a single point of control because all of those devices belong to you. On the other side, if you have something like multi-peer and you need some kind of, let's say, decentralized identity, it is not an easy way to go. I would say that the closest that there is something like what Git allows you to do, so basically creating a key value pair and share it with others and use this pair as your identity in fact. So yeah, something like that, because it's like still not a solved problem in my opinion, especially at scale, let's say. Yeah.
One very quick question you can take.
I really love this vision, and at the same time, I'm a bit worried about the engineering complexity of making it. And what I see is that it also costs a lot of money to pay the people to work on a solution. The centralized is often simpler.
I would
Any
say
thoughts on that?
I would say that centralized is simpler nowadays because we've put a lot of work over the last few decades, right? Because technically it's not really simpler, it's just we made it more tame, let's say, right? And I think it will be the same here if there will be interest in simplifying those things and making them standard, which is again shout out to iRock because they made a lot of hard things possible, like relaying information through multiple devices in end-to-end encryption and stuff like that. It's something that in the past was extremely hard to do by yourself. Now you can use basically a framework for that, right? And one of the reasons why I started with economic model is that those things can be done, like everything can be done, right? And except that there needs to be an economic incentive to do that. So somebody needs to want to pay for that or put a work into this, and this is why I started with economic incentives. So to explain why this might be economically feasible.